So hello everyone, welcome back to the channel. Today we are going to discuss the problem find anagrams in a linked list. So given a linked list of characters and a string s, return all the anagrams of the string present in the given linked list. In case of overlapping anagrams, choose the first anagram from the left. So let's discuss the question. So for example, we are given the sequence ABC and this is the linked list which is given. So first we discuss what is anagram. Anagram of ABC are the all the permutation like BAC, CAB, CBA, BCA, ACB. All the permutation are also known as anagrams. So here we are. So basically, what is our aim? Our aim is to count the frequencies. Like A's frequencies is 1, B's frequencies is 1, and C's frequencies is 1. So we have to check in the linked list whether they are continuously coming. A is equals to 1, B is equals to 1, C is equals to 1. If they are coming, then that means this is the anagram in the linked list. So let's discuss in this example like A, B, C is an anagram. Next, BCA is also anagram because one time BCA coming as we required. Now similarly BCA is also anagram. One time they are coming. But we are given in the question we want non-overlapping anagrams. That means we have to choose only this and this. Also we are given the one which comes first, we have to take that. So here ABC is coming first. So we will take this. We will reject this and we will take this. So this is the question. Find anagrams in the linked list. So here you can see we will use a sliding window technique. So let's discuss what is a sliding window technique. Let's say I have the string as A, B, C, and A, B. And here I have given the pattern like B, C, A, and A. So let's say I will take A. Now A's count is 1. Here we will take A's count is 2, B's count as 1, C's count as 1. We have to achieve is our target is this. Okay, so A's count as 1. Now next time A's count as 2. Now A's count is 2. Now next time B's count is 1. Next time C's count is 1. We have achieved whatever we want. So this is the sliding window technique. So let's discuss the proper approach, how we apply the sliding window technique here. So here we're given the string as AABC pattern. Here is the array. So let's consider, instead of considering it as linked list, let's consider it as an array so that we can understand in a better way. So first we take a start pointer as we take in array in sliding window technique, and here is the end pointer. So initially the frequency of this is A2, B1, C1. And here we maintain the count to one variable. We will store, let's say, in MP1 map. So here count 1 is total number of A, B, C. 3 type of characters coming, 3. Okay. Next, here we also take, for this we will take MP2, another map, and count 2 is initially equal to 0. So our basically aim is to achieve count 1 as 3. So let's see. Like start is 0 and is 0. Now initially I will see that A. So we will increment the count of A by 1. Now we will move the start pointer ahead. Instead of shifting the start pointer, let's shift the end pointer. Let's keep the start pointer at it ahead. Let's shift the end pointer. Here we see A's count as 2. A is again found. A's count as 2. Now, understand it properly. Like A is 2. A is 2. That means one character is properly achieved. That means we will increment the count 2 by 1. Now, next time we will shift the end pointer B. Now, here we will also come. So, B's count become 1. But here we can see we have properly achieved B. So, count 2 will become 2. Okay. Now, next time, end pointer will shift ahead. Now, here we can see C's count become 1. And we have properly achieved C. So, count 2 will become 3 here. So, here we can see count 1 is equal to count 2. That means I have found the anagram in the linked list. So what will be our first answer? First answer will be A, A, B, C. This is the linked list. Also, we have to keep this as null. We will see in the explanation part, coding part. Next thing, now we can see we want non-overlapping. That means if there is, let's say, AABC, this one is also found, then it doesn't matter. We have to take first. We don't need to overlap. So instead of uh, taking this ahead, let's shift both pointer ahead. Start will also start will move Start will move to 4 and end will also move to 4. Why? Because previous one are not taken again. Previous characters are not allowed again, since otherwise they will become overlapping. So we will not take them. Now, now also we will clear the whole map. We will clear the whole map. We will clear the whole count. Now, next. Now initially this count, let's keep this as 3 because A, B, C 3. Now it was initially equal to 0. Now we can see A's count become 1. So let's make this 1. D's count become 0. So let's make it the 0. Now, so first shift this pointer, end pointer ahead. D's count becomes 0. Now we can see in this map, like D will be 0 only. If it is not there, like D is 0. So here D will become 1 because 1 D is again taken. That means here extra character is coming which cannot become the contiguous. So we will remove all the character until this D is removed. So that we do in sliding window technique. So we will shift the start pointer until this D is removed because it is extra. So start pointer will come here. So A will become 0. Now D is again there. D is again 1. That is greater than the MP1 map. So we will shift the start pointer again ahead. Now end pointer will also come here. And this will also become 0. So let's remove this. Instead of keeping it 0, let's remove. Now we have seen that end is equals to B. Now B's count will become 1. Now we can see that B is properly achieved. That means count will become 1. Now next time, let's shift the end pointer ahead. Now we can see C's count will become 1. So we can see C is also properly achieved. That means one count is properly achieved. So we will make it 2. Now, next time, we will shift end pointer ahead. So A's count will become 1. But A is not properly achieved. A is 2, but here A is 1. So we will not make it 3. Okay. So next time, we will make this end ahead. Now A's count will become 2. So A is properly achieved. That means count 2 will become 3. Okay, so that means count 1 is equals to count 2. So this one will also be the answer. That means from the start, this one linked list, this one, B, C, A, and null. So this is the answer. Vector we return as an answer. So end pointer will come outside. So it will less than n, or we can say linked list, it will become null. So that is the answer. So here we can see why we are taking MP1, MP2, okay, fine. But why we are taking count 1 and count 2? Count 1 and count 2 are taken so as to optimize this. If I will take every time MP1, I will add. Then I have to compare with MP2 again and again, for which will make it big of n for extra within the iteration. So instead of taking it extra, we are making the count 1 variable, count 2 variable, whether total count is achieved. So if total count is achieved, so we will say increment count when the count will tell us that whether all characters are achieved, whatever we want. So that is the idea behind taking the count one and count two. So let's discuss the approach and here like okay. So first we take the vector node star answer where we store our answer. Now here we will take the start pointer, like we take start is equals to 0. Like if I tell you, like in array, we will take start is equals to 0 and end is equals to n minus 1. So instead of taking that, we are taking the start as head and end as head. Star end as head. Now we can see like s dot length initially. Now the pattern string, whatever the pattern we have to match, this is a pattern string. So let's take all the parameter, like we have taken unordered map mp1. Next, what we've taken, count1, which is equals to total map size. Like here we have taken mp1 is count1, 1 2 3, map size 3. So first we calculate what is the map size. So for that we will traverse the whole pattern string and mp1 of it plus plus. So in count1 is equals to mp1 dot size. That is, now this is the whatever string we are traversing string, or we can say traversing linked list, whatever we can say. Unordered map char int mp2. Now here we create the count to initially as 0. Now what we are doing, what we are moving, we can move start and end, but I am moving end pointer. So while end is less than is equals to n, so instead of doing we will do end is not is equals to null. Okay, now mp2. So in map, like a is coming, so a's frequencies will be incremented and data plus plus. Okay, now so what I said, like if the target like a was 1, now a will become 2. If a will become 2 here and here, so one character is properly achieved, then we will increment count 2 by 1. So then we will say that if mp1 and data is equals to mp2 and data, then we will increment count to plus plus. Now here comes a different case, like whenever extra character is found. Let's say for example, here is some example that can give you, like a b b c, and like here I have a b b c. So here the count of a is 1, b is 2, c is 1, count 2 is count 1 is already equal to 3. So here a is 2, b is 2, c is 1, count 2 as 0 initially. So initially they are 0. Now we will move end pointer, a's frequency will become 1. So a is achieved, whatever we want, a required 1, a is 1, count 2 will become 1. Now when we'll come here a, so this a is extra, that means it will become 2. So in the anagram, we do not require this. So we have to remove this first. Otherwise, it will distort the anagram. So we will remove this until a will become 1. So we will remove it and it will become 1 and shift this end pointer. Instead of end pointer will be here, but we will shift the start pointer instead. Start pointer will come here instead of this. That is the idea. That means we have to, if extra character is found, that will distort our anagram. So we will remove this until a will become 1. Okay, so that is the idea. mp2 and data. That means whatever character we found, if it is greater than the character we want, so we will say that if mp2 start data is equals to mp2 end data. Now this is something different. Like here is example, like a b c a, and a is 1, b is 1, c is 1, like a b c a. Let's take this something like a b a c a. So here we can see a is 1, b is 1, c is 1, that we require. So here we can see a will be 1, a's count will become 1, b's count will become 1. Now a's count will become 2, which is not required. So we will shift the start pointer here, b. But like here count 1 was 3. Here count 2 was 2. Why? Let me tell you again. Like here, a will be 1, b will be 1. So A was 1 achieved. So count will become 1. Count 2 will become 1. Similarly, B1 achieved. Count will become 2. So here end pointer will come here now. Now A is greater. A will become 2, which is not required. So we will remove until all character become equal. So A will be removed. It will become 1. Okay. Now B will be removed. B will become 0. So whatever B was achieved, now it is not there. Na? So we will remove this count. Count 2 will be also become 1 because B is removed. That means this string is left, not B. So that is the reason why I'm checking this condition that if MP2 start data is equals to MP2 end data because we added that count when they were equal. And now if they're equal again, that means we are removing that. So we will remove count to minus minus. Now MP2 start data minus minus. Now start is equals to start next. We will move the start plus plus, or we can say in the linked list start is equals to start next. Now, okay. Now, if our count 2 is equal to count 1, that is our target is achieved. So we will push the answer, the node that is the starting point of the linked list. And also we have to mark the end next is equals to null, and we have to shift the whole sequence. That is whatever we were doing, like here ABC, like in this ABC, ABC, ABC. So here target was achieved, so we have to point this to null, and we have to shift this ahead. So this will become new end and new start. Since we don't want overlapping, so that's why we have to shift all things. Well, we shift start and end pointer ahead. So what we will do, we have to set end pointer as next, but we will lose the add pointer. So we will store it in something different variable, and then start is equals to ahead, and then end is equals to ahead. Both will shift it ahead. Now MP2 will be cleared because now it's not required. Count will also become 0 because we found the sequence and we don't want it to overlap. So we will clear whole map and we will shift whole ahead. Now at the end we will return the answer, whatever answer we were storing in the vector. So let's check whether it's working fine. So here's something. So here when we will change the MP to start data and MP1, it is working fine. By mistake I wrote it start. Then let's submit. So now it is working fine. So this question was all about sliding window technique, and this was all about. So thank you. Have a nice day.